All right, folks, I'm recording a video here for Section 5.2, which has to do with what's called one-to-one functions. And we're going to be discussing this quite a bit when we discuss more about inverse functions. Now, let's take a look at a few examples here. And in this first question, it says, if f is a one-to-one function and f of 4 equals 3, then f inverse of 3 equals blank. Well, first I want to make a comment here about notation. You might remember that we write f of x to mean some function evaluated at some x value. So for example, if we were to say f of 4 equals 3, then this 4 is the x value and this 3 is the corresponding y value. So if I was to write this in xy notation, this would be the point 4, 3. All right, but we're using a notation here of f with this -1 symbol here. Now this doesn't mean an exponent. F inverse f with this, what looks like an exponent -1 is really the inverse function. And what the inverse function does is it swaps the x and y value. So if the original function, so this, be careful, this is a special notation. That means the inverse function. It doesn't mean an exponent of -1, even though it looks like an exponent -1. In this context, it means the inverse function. So if on the original function, we had the point 4, 3, what the inverse function does is it swaps around the xy values. So I'm going to swap this and make it 3, 4. So this is now the inverse function by swapping the xy values. So what they're asking about here is if we were to take the inverse function and evaluate it with an input of 3, what would the output be? Well, we can see right here the output's going to be 4. So this example is just trying to emphasize that when you work with an inverse function, it swaps the x and y values from the original function. And so if I was to come here on this drop down, the only answer here that would make sense is this answer 4. All right, let's go to another example. All right, now when we're working with a function, we want to know if a function is called one-to-one. So if we have a function, let's say f of x, the question is going to be, is it one-to-one? One-to-one means every x value matches up with a given y value, and that y value matches up with an x value. It's like a one-to-one mapping. There's no case where there's a repeated x or repeated y if you were to list out the ordered pairs for the function. So we want to know, is it one-to-one? Well, to answer this question, we can use something called a horizontal line test. And what a horizontal line test does is it answers the question about the function being one-to-one. Let me give you a couple of examples here. Let me draw a graph. Let me draw 2 graphs. And this graph I'm going to draw looking like this. And this graph I'm going to draw looking like this. All right, so here's what you do. Imagine drawing any horizontal line that you want. So I'm going to draw some horizontal lines here. Here's a horizontal line. Here's another one. Right, imagine drawing any horizontal line. I'll do the same thing over on this graph too. For the function to be one-to-one, the horizontal line can only intersect the graph at most 1 point. So notice in this left example, here a horizontal line is intersecting only 1. Here only 1 point. Here only 1 point. On the right side, though, a horizontal line is intersecting the graph more than 1 point. Looks like 2 points here. So the rule is, If every horizontal line intersects the graph at one point, at no more than 1 point, then we call that a one-to-one function. Okay, so to answer the question, is it one-to-one, you could perform this horizontal line test. And if any horizontal line intersects the graph at no more than 1 point, it's a one-to-one function. If a horizontal line intersects the graph at more than 1 point, then it's not one-to-one. So in my example, I would conclude that this function here on the left is one-to-one. And this function on the right is not one-to-one. And you might say, well, what's the implication? Well, this tells us whether the function has an inverse or not. If the function is one-to-one, it has an inverse. So this function is going to have an inverse. If the function is not one-to-one, it does not have an inverse. No inverse. All right, so the answer to this question you can see is one-to-one. All right, let's look at another example here. Now, it turns out for an inverse function, the domain and range swap around. So let me draw a little table here to help illustrate this. So let's say I have a function, and over here I'm going to write its inverse. And let's say for the function I have a certain domain, and I have a certain range. I'm just going to call the domain A, and I'll call the range B just to make it a little easier to reference. What happens with the inverse function is the domain and range swap around. Remember, when you go from a function to its inverse, the x and y values swap. So it makes sense that the domain and range should swap also. Remember, the domain is the set of x values. The range is a set of y values. But if you swap x and y's, going from the original function to its inverse, then what's going to happen is the domain and range are going to swap. So then the domain for the inverse is going to be b. So it means whatever the range was for the original function, it's going to flip and be the domain for the inverse function. And whatever was the domain for the original function is going to flip and be the range for the inverse. So basically, domain and range flip around, just like the x, y values flip around. So if the domain of the original function was 3, infinity, the range of the inverse should be exactly the same because the domain got flipped. In this example, the domain flipped to be the range. All right, let's do a couple more. All right, let's take a look at this one. It says if f and g are inverse functions, the domain of f is the same as the range of g. Well, yeah, that makes sense because we just said, so what they're doing in this example is instead of calling it f and f inverse, by the way, I should have made this f inverse here. I should call that f to the -1. If these were inverses, so what they're calling this is g, then the domain of f is the same as the range of g. Yeah, because we said if the domain here is labeled as a, it's going to flip to be the range of the inverse function. So this statement makes sense, it's true. All right, let's take a look at this question. Let me clear the screen here. Okay, so this says, what about if 1, -4 is a point on the function f? Which of the points is on the graph of its inverse? Well, remember, when you go from a function to its inverse, the x and y values swap around. So if 1, -4 is on the original function, then you got to flip it to make it -4, 1 on the inverse function. Okay, so the XY values always swap from a function to its inverse. All right, let's do a few more here. Here's some questions that ask you to use the horizontal line test. So what we mentioned a few minutes ago is if every horizontal line intersects the graph at no more than 1 point, then the function is one-to-one. So I'm looking at this example and I'm imagining drawing different horizontal lines. Here's one, here's another. Well, any horizontal line is only going to intersect the graph at 1 point. When that happens, we say it is one-to-one. So in this case, yes, the graph is one-to-one. All right, let's look at another one. Here's another graph. Well, in this case, let me again use the horizontal line test. I'm going to draw any horizontal line. But I could see right away that these horizontal lines are intersecting the graph at more than 1 point. Well, that means this fails the horizontal line test. That means this function is not one-to-one. So the answer here is no, it's not one-to-one. All right, let's do one more example here of this kind of question. And again, this is the same question. What about this graph? Well, I'm going to use the horizontal line test. Here's some horizontal lines, but I could see they're only intersecting the graph 1 point. So that means yes, this passes the horizontal line test. So this function is one-to-one. It also means this function does have an inverse. All right, let's look at maybe one more question. All right, let's take a look at this one. This one's a little more involved. And so this one says, the graph is given. Find the inverse function Find the inverse function. Okay, so here's what we want to do. For each one of these points that are showing up, I'm going to zoom in on this to make it easier to work with. So this is the original function f of x. I want to sketch out the inverse function. Okay, so this is f of x. But remember, the inverse function swaps the x and y values. So let me come down here. This is -5, -5. I'm going to swap the x and y. But if I swap the x and y, it's actually the same. It stays -5, -5. So I'm going to draw that point here in red. Let me come up to this point. It's -1, +1. But for the inverse function, I got to swap it around. Well, that's going to be 1, -1. So let me plot that. Here is 1, -1. I'm going to do it in red for the inverse function. Let me come over here. Here's the point 1, 2. So its inverse would be here at 2, 1. And one more. Here's the point 2, 3. I'm going to go up to 3, 2. And here's the inverse point, the inverse function. You could probably see what's going to happen if I connect these with a straight line, these line segments. What happens is the graph of the inverse function here in red is the mirror image of the blue graph of the original function across this diagonal line y = x. So whenever we are interested to graph the inverse function, all you have to do is imagine plotting the mirror image of the original function on the other side of that y = x black line shown on this graph. Okay, so now I could go and look at these answer choices, and I could see that the only choice that matches up to the graph that we just drew is answer B. And again, you can see here the red graph is the mirror image of the blue graph across this black diagonal line. So it looks like the answer here is graph B. Okay, hope this is helpful as you're getting started in section 5 too.